Okay, padayon lang kita. Dako na ba ton oras? Kailangan ta isumpay. But anyway, kita untaan next na problem between this is we have already computed the work done by your normal force and by gravity. So we've already done that. And then next question letter B is what is the speed of the rock as it reaches point B? So speed, so basically you have to relate it to ano ba't may speed? Kung baga waray kinematics na solution, pwede mag-kinematics again, pero para di na halaba. So that would be your kinetic energy. Or, actually, ini yung concept, kay may daya, amin actually ang konsepthan when total mechanical energy is not conserved. Meaning, di rila kinetic and potential itaada. Amo ito karusignon. Because your mechanical energy will just be the conservation of your kinetic and potential. So, amo ito yung term nga when not conserved. What do you mean, sir? Kita na lang niyo dito ang discussion actually. So, diretso ko man latiya. But anyway, I think kuha ko man mga formula. Di man, impulse momentum man. Total mechanical energy when it's not conserved. Again, kung conservative total mechanical energy, waray ini nga other. Yan na, di man yan pareho lang ginhatag, di ba? May dani mo circle, traveling ko na sa circle. So meaning that other would be the work by friction. So ini kinetic energy ng potential, that is animula iton ka ng gravity dida nga side. Pero kay may daman na kontra ito, which is actually given ditong problem, which is kanan friction. I think it was given by the problem. Di ubos. Di man? 0.22 joule. An kanan imo frictional force. The work of friction is 0.22. So basically what it means, to calculate that velocity, you have to analyze it from there. Meaning, may daka other which is that 0.22. Other which is 0.22. Ano mat nga 0.22? Naiban, nadugang. So kung naiban niya, that should be a negative. Because that frictional force opposes that motion or that change in kinetic energy. So basically, you would have U1 plus K1 plus other, work of other, so that's the frictional force, U2 plus K2. So again, it aton rolled out ini nga aton K1 start from rest, so this would be 0. Wala ka velocity kasi igbaw. Tapos may velocity ka ubos pero wala ka lot potential la ubos. U2. So basically, aton formula is U1 plus W other, which is a work and frictional force, is equal to K2. So, if you substitute that, U1 is 0.98 joule. That is your potential energy igbaw. Di man, calculate natin, the gravity. Amo ito ang trabaho ng gravity. Magiging work itong gravity kung ipaslide itiya. Because that gravity will pull. And that is the work of gravity. That force over that distance han imo, which is potential energy. Actually. So, 0.98 joule. And then the other is a frictional force that should be a minus 0.22 joule. 0.22 joule. Again, that minus because that is opposing that gravity. Opposing that gravity or that y-axis. Your displacement in y. Which is equal to 1 half mv2 squared. Okay? So, your 0.98 minus 0.22, tapos i-times 2 mo tiya. So, I could have your V2 squared which is equal to 2 times 0.98 minus 0.22. So, igawas ko na lang unit ng J. So, that would be, J is Newton meter. So, that would be kilogram meters per second squared times meter. So, that is Newton meter, the joule. Okay? And then, all over your mass, ini nga M. So, that mass is given to be 0.2 kilogram. Cancel sa meter squared second squared. So squared kasi ini square root nimo, basically you would have that V2 to be the square root of square root of 2 times 0.98 minus 0.22 all over 0.2. And that will give us 2.77 or 76 inter-significant figures. Pero I think duhala. Okay, tagduhala din eh. So that would be a 2.8. But again, not on quiz. 2.7. 2.7 lang ang answer. Waray conversion. Okay? But the proper answer should be 2.8 meters per second. Okay? So that is your velocity 2 from your um, conservation of teringan, not mechanical energy. So when the mechanical energy is not really conserved. So C, of the three forces acting on the rock as it slides down the bowl, which are constant and which are not? Explain. So actually, di mo ito constant dida, ani mo gravity because your gravity is always mass. As long as diri kahirayo Earth, that 9.8 is always equal and your mass doesn't change because your mass doesn't really change. Diba? Nag-iiba lang imo ano mo G. Pero kung ada kat babaw to na, as long as you're not significant far from Earth, the G would be 9.8. So that weight would not be varying. Pero ang imo frictional force, so as you can see, ginhatag niyan frictional force kay medyo complicated ito yeah, because again, your frictional force is varying. So meaning, your frictional force is varying on this side. Actually, didi nga igba, wari ka pa frictional force kay wari ka man Y component. Diba? Team friction kasi didi nga side, ti pa igbaw. Taka ka nimo, animo gravity kay ti pa ubos man. So, animo gravity, nati kang man zero, so your frictional force at didi igbaw, nati kang lote zero. Okay? And also your normal force, didi igbaw. So, your normal force and your frictional force varies. Okay? Itim frictional force na vary from 0 to a maximum didi, itin mo normal force amo gyap somewhat didi to didi. From somewhat 0 to somewhat didi maximum iti mo normal force wherein your normal force here has a maximum of equal to the weight itself. Okay, didi nga side. Okay? Because didi, mag-summation sa Fy ka nga ni mo normal force ni pegbaw, ani mo weight ti paubos, hira lang nga duduhat magkontra. So, if that is equal to summations of forces on Y is equal to your weight is going down negative minus normal force. Your normal force is related to your here equal. Somewhat minus ani mo kanang frictional force dito nga side. But anyway, wala man kita aruihin. Nagpakanalahin at varying. So, varying forces are normal force and your frictional force while the constant is your weight. I mean the weight that was given from just the just point B. What is the normal force on it due to the bottom of the bowl? So just as the rock reaches point B, what is the normal force? So the normal force would be equal to Tira. We have to compute. Okay, compute kita. Normal force, mo na. May papakompute man. At the bottom, this is your rock. It has velocity going there. And then it has weight. It has normal force. And it has a frictional force. That summation of anyway, summations of forces on Y will tell you that it is equal to 0 at the bottom. Kaya ano, waray ka man displacement or x-axis na kasi ya. Diba? So, ano mo mga Y? 0. Ano mo summation forces on Y? With respect to your acceleration, which is 0. Y. Pero x may da ito ya. Of course, it's done by the frictional force. Negative. Tapos ano mo y nga total ano mo weight nga total, ano mo work nga total. Ang mga tagayang kinetic energy nga V2. Diba? May acceleration niya tapos kung may friction palagi hapon niya, anyway, ang problem, diri kasi tigang di abot nga di. Ano mo la problem is, kaya bakit ako sisunod lang problem na hindi naman problem? Then anyway, lahat atong concern, summation sa FFO is equal to 0, then you would have your normal force minus your W is equal to 0. Then your normal force would be equal to your weight, mg. So, your normal force would be equal to mg at the bottom, which is 0.2 kilogram multiplied by 9.80665 meters per second squared. And that will give you your normal force, which is 0.2 times 9.80665. And that would give us 1 or 2 Newton, 2.0 Newton, your normal force. Normal force, just the normal force on it uh, due to the bottom of the pole. The normal force is 2 Newton. So thank you guys for listening.